homework. I know, right? I know. Okay, for real though. This is what's gonna be on your test, okay? So you're gonna have lots of tricks.
So that's for tomorrow?
Tomorrow,
Oh, that's
yes.
so hard.
I know. But if you've just written down everything I said, you'll be fine.
It seems really hard though.
I never do this. Landon's gonna ace it.
Yeah.
It's called guessing.
Right? It's not a Mark Sparks, it's a Harper test. So you get what you get.
Oh, what? And you don't throw a fit.
Exactly.
I did.
How many questions are there?
50.
Okay, great.
All right. You got that?
Yeah.
Find us. There. This says 10 and 11, but it's 7 and 8 on yours. I'm not really sure why. Like it's 6, 10, 11. So apparently he doesn't know how to count. Whoop. It's too tiny. And then there's 12 and 13. There you go. All right, we good?
Yes.
All right.
My name is Brady.
Lane, can you see the board?
Yes. Yeah, he is. He can.
Okay.
Do you need more fake laughter?
No.
That's not fake. You're really just laughing.
All right. Let's get to page 553.
Math time. Math time. So what? Math time and math time.
All right. So today we're going to start talking about the unit circle. And most of it today is just terminology. Okay. By the way, is everyone who's not here, like officially here? Kobe is officially
Kobe
here.
and Tyson are officially here.
Oh, yeah, they play baseball. Baseball left.
Wait, officially you mean by like absent? Yeah, Kobe's absent. Where's Alyssa? No, it actually is.
She's
I
so
really didn't
sneaky.
cheat, sorry.
That's like a ninja. Alex is with East, and Hunter's with FCCLA. I think that's where Nadia is.
That's where Kinsey is.
Yeah.
Oh, I thought leadership was done. I was just
Nope. Okay. So first of all, let's begin by drawing 3 different circular angles in standard position, measuring 215 degrees, 575, and negative 145. As you draw the angles, as we draw them together, pay close attention to the detail. Oh, all right. Pay attention to the details that we put on each picture. Okay. So 215, let's just real quick. How many degrees is this from, we're going to start here and we go to here. 90. And this is, and that's, and then we're back to 360. So this is like 0 degrees, 90 degrees, 180, 270. Okay. And so we have to go to 215. So we're going to start right here. That's 0. And we're going to go, it's going to have to go like a little bit past 180, right? So I don't know. Not quite halfway, because halfway would be 45 more degrees. I think there's only 35 degrees difference. So like right there. So from here to here. That's 35 degrees right there. Okay. So we went all of 180 plus like 35 more, and that's 215 degrees. So what about 575? Yeah, I'm gonna have to go all the way around and once, and then
And then 575 minus 360.
215.
215 again. Right. So it's gonna be in the same place, but it's gonna look different because you're right. I'm still starting here, and I go all the way around, and then to right there.
Smell can.
Yes, it's like a snail. Okay, now what about negative 145?
Backwards, but still 215.
Backwards, but still equal to, so it's gonna go right here still.
Yes.
It's gonna start here, and it's
Go
going
down.
this direction. And that's still 35 degrees. Okay. Hey, what do all the angles have in common with each other?
35 degrees.
Okay. Yeah, sort of. Okay. This is called the initial side, and they all have the same initial side. And what is that initial side called? What is this?
The x-axis?
Yes. Same initial side, which is the positive x-axis. They all have the same terminal side. That terminal side can be located anywhere, but this is called the term where it stops. That's called the terminal side. Terminal, get that? And then this is what, sorry, we're saying they're all that 215. Actually, what we're going to look at is this 35 degrees. They all have the same reference angle. The same reference angle. And the reference angle is the positive acute angle that the terminal side makes with the x-axis.
So the terminal side, the negative x-axis.
Hang on one second. Hold on to that question. The positive acute angle. The terminal side makes the x-axis. Okay, we want that reference angle to always go back to the x-axis. Now you were asking about the negative x-axis.
What's the terminal side of negative x?
The terminal side is where the angle stops. That's the terminal side. So
Oh.
here, and right there. That's the terminal side. The reference angle is the angle that's made with the terminal side and the x-axis. So that's 35 degrees. Okay. What's the one difference that they all have?
How far in what direction they went?
Okay, so it's actually kind of the direction of rotation and the number of quadrants that terminal side passes through. Because think of it opening like they were like this, and it just opened up. Okay, so that terminal side starts out and it passes through quadrant 1, it passes through quadrant 2, and then it stops in quadrant 3 for 215. For 575, it opens up and goes 1, 2, 3, 4, 1, 2, 3. And then for negative 145, it just goes 4, then 3. So it goes the other way. So there's actually, it says what's 1, but there's 2 differences. The direction of rotation. I can't spell rotation. That's what I started to spell, yeah. And the number of quadrants the terminal side passes through.
Maritime testing.
No, she's sick. She's messaging me right now, though. We're going back and forth over some math stuff. Do you need me to tell her something?
Oh no. No, that I can't wait to do the thing in engineering. Are you guys playing Scrabble?
No, we're talking about math training for the summer.
Really?
Mhm.
Oh, I got to sign up. You know, life is expensive. I
Why
gotta bring $46.
46?
30 for a prom ticket because apparently Sydney can't buy her own.
Right.
First of all, yeah,
Mhm.
you choose to see, and then $12 for a shirt. I don't even want it, but I guess the parents want it. And then for a picture frame. I don't even want it. Yeah, the parents want to get one. Tomorrow's the last day.
It's tough.
Bye.
It's a tough life.
It'll bug. Oh, my bad. I was gonna flash it off.
All right. Okay. Based on what you've seen so far, you've seen so much right here. What are the 4 vital things that all circular angles must have when drawn in standard position?
Initial side.
They need an initial side, which is what?
X, positive.
Mm-hmm. The positive x-axis. Always. Always. Positive x-axis. What else do they need?
Terminal side.
They need a terminal side.
I can be doing one, two, that's our.
I asked if you needed help with anything.
And I asked what I needed help with. You're my teacher.
Yeah, well, I can't. There's so many things, and like I'm not qualified for all of that. That with which you need help.
Not psychologically, just the
Oh.
math.
Oh well, I didn't know that you were
And the
that
relationship
specific.
ones. I'll take those.
I think I'm checking out on that one.
I'm just kidding. I told you.
All right. 3, you need this thing right here. You need your arrow of rotation. And then the last thing is you definitely need a labeled reference angle. Oh, I forgot I was going to stand up because I'm doing this thing where I stand up more. So, let me get my chair out of the way. I forgot about that. My watch says I don't move enough. All right. The 3 angles drawn above are called coterminal angles. So let's give a definition of coterminal angles. Coterminal angles are angles that, okay, there we go, I'm done. What do they do?
They have the same reference angle. No, they have equal terminal sides. They have the same terminal.
Both. They terminate in the same position.
So I was right.
Yeah, they're both right. Which means they have having the same reference angle. But they have different arrows of rotation. So coterminal angles are angles that terminate in the same position, having the same reference angle, but different arrows of rotation. We good? That's a gap that's not gonna crush your finger. That's gonna like cut off the whole arm or
I
something.
can't bend.
All right. So now we're going to draw the angle negative 470 in standard position and find one positive and one negative co-terminal angle with negative 470 and draw them in standard position. So first of all, let's draw negative 470 in standard position. If I'm going to draw negative 470 in standard position, like where am I going to end? Which direction do I need to go?
Left of the 90. Like,
Do I start going up or start going down? Yeah, I'm going to start with going down because it's negative. So if I go to here, that's 360. How many more do I need?
110.
So that's 90. And then about 20 more right there. This right here is the reference angle. Remember, the reference angle always goes to the x-axis. It always goes to your x-axis. And when you're doing negatives, a lot of people try to get this angle right there as your reference angle. And that's not how it works, okay? Your reference angle is always drawn back to the x-axis. So what is this angle right here? From here to here. 70 degrees. So my reference angle is 70 degrees. I put my little arrow, my directional arrow on there.
Are you really recording right now?
Mhm.
Oh.
All right, so draw the angle in standard position. Check. Find one positive and one negative co-terminal angle. So positive, I'm going to have negative 470. If I just add 360, that's not going to get me out of being in the negative. So I'm going to add 360 times 2. I could add like 360 times 7. I could stop at 2 because that gets me there. What's 470 plus 360 times 2?
1190.
No.
250.
250 degrees.
Oh, negative.
And then I do need one negative coterminal. So what is that? Negative 110? Okay, we're going to start talking about how to get a radian measure now. And I think we did radians last year in Algebra 2 for like a minute.
A little bit.
Yeah.
Very, very.
Yeah. So we're going to get into that just a little bit more right here.
I would make my son Grady.
Gradient. Okay.
Little rebel.
Call him Grady. I had classes with a person named Grady, and he was a creep. So just watch out. The only Grady I've ever known is a creep.
I mean, yeah.
Grady.
Candace Jones.
Anyway, all right. Just as segments can be measured using inches or centimeters, angles can also be measured using different units. So the two units that we use most are degrees and radians. A radian is based on what's called the unit circle in trig. Okay. By definition, does anybody remember what the unit circle is?
I know 1 radian is 180 degrees.
Okay.
2 pi over 3.
That's the thing.
Pi
Yeah.
r squared equals the circumference.
What's the radius of the unit
1.
circle? 1. Okay.
Oh, yeah.
And what's the center of the unit circle?
1.
No. 0, 0. Okay, so unit circle is a circle. Imagine that. The unit circle is a circle whose center is 0, 0, and whose radius is 1. Look, there's a unit circle right there. It's beautiful. I think that's the cart with the. See, I got blinds. You didn't even notice I have blinds now.
I did.
Oh, good job. Good job. But I think that's the cart upstairs because just this side of the building's getting blinds and they did downstairs and now they're doing upstairs. Because I don't know if you know this, but like there are a lot of coaches located upstairs and coaches don't teach classes in the afternoons. So most of the afternoon upstairs is empty,
Oh, wow.
or most of it is. So
Hey,
anyway.
did you hear a loud bang? Third period. Very end.
Yeah, maybe.
My backpack broke again.
Oh.
I put it on and it snapped.
All right.
85,000 money.
It's time to get a new backpack.
No, it's not.
We'll start a GoFundMe. All right, find the circumference of the unit circle. So circumference is 2 pi r. And what's the radius of the unit circle?
Pi r squared.
What's the radius of the unit
1.
circle? So the circumference of the unit circle is 2 pi. All right, by what must 360 degrees be multiplied to obtain the circumference of the unit circle? So 360 times something gets you 2 pi. So I divide by 360. And x equals pi over 180.
If we would have done this last week, I would have gotten the question right in football.
Sorry, I'll work on that next year. All right. To convert from degree measure to radian measure, so you would take your degree measure and you would multiply times pi over 180, and that would get you your radian measure. We're going to leave it in, it's called in terms of pi. So pi will be part of your answer. You don't multiply it out. And then to convert from radian to degree, you take your radian measure. And you just flip it. Multiply it times 180 over pi, and that gives you your degree measure. So 90 is degree. So 90 times pi over 180. Well, that's 1. That's 2. So that would be pi over 2. See how I canceled that out?
Yeah.
Fractions. Negative 235. 235 times pi over 180. Let's see. I'm pretty sure. I mean, I know 5 goes into both of them. I don't know how many times. What is that? 47 and 36. So that would be negative 47 pi over 36.
So we could do this on the test.
Mhm.
Or is that memorization?
You won't have time. I mean, you could, but you won't have time because it's timed.
Oh,
I don't remember.
well, yeah, we did it last year.
You did it last year, though.
But you also made us move our squares.
So if I want to go the other way, if you forget, just make sure you set it up where If you have a pi, pi's cancel out. If you don't, you want one on the answer. So you put it at the top. So 3 goes into 180 60 times. 2 times 60 is 120 degrees. Negative 13 pi. Move that up here. Negative 13 pi over 6 times 180 over pi. The pi's cancel. 6 goes into 180 30 times. Negative 13 times 30 is a negative 390. So negative 390 degrees. I know, right? You got 12 minutes. All right, find one positive and one negative coterminal angle with negative 4/3 pi or negative 4 pi over 3, either one, and draw them in standard position. First, do this by converting it into degrees. Okay, so if I want to convert it into degrees, it's going to be negative 4 pi over 3 times 180 over pi. So that's a negative 240 degrees. So positive. Negative 240 plus 360. That's 120 degrees. So I'm going to start here. And I'm going to go to like right here. That's not very loopy. Oh, there you go. What's my reference angle on this?
30 degrees.
Go to the x-axis. What's this angle right here? 60 degrees. That's 60 degrees. Bless you. All right, so I need a negative. So negative 240 degrees minus 360 degrees would be negative 600. So I'm going to start here. I'm going to go all the way around one time and then come back to here. And that is still 60 degrees. All right, this is the fun one, okay? Find one positive and one negative coterminal angle with negative 4 pi over 3. Draw them in standard position. Do this without converting the given angle into degrees. So is this picture going to change any? No. What's going to change is the label for it, okay? So if I have negative 4/3 pi and I want to make it positive, so it's going to be my positive one, I have to add 2 pi. Two pi in terms of 3 would be 6 pi over 3. So my answer is 2/3 pi or 2 pi over 3. So when I draw this, it's still going to start here. It goes here. And it goes. Whoop. Now, what is that reference angle right there? 60. What is it in radians? What's 60 degrees in radians? What? Nope. This is 2 pi over 3.
1/3 pi.
Okay, so it's pi over 3.
Yeah.
Negative. I have negative 4 pi over 3 minus 2 pi, or negative 4 pi over 3 minus 6 pi over 3. It's going to be negative 10 pi over 3. So it's the same thing again. It's going to start here, and it goes all the way around to right here again. And that's still pi over 3. Okay. Theta 275. What I want is what quadrant it terminates in and the angle measure of theta prime, which is the reference angle. So if it's 275, what quadrant does that terminate in?
3.
I'm
4.
gonna start here.
1, 2, 3, 4.
And it's going to be in 4. It's right there. What's the reference angle?
85.
85 degrees. So theta terminates in Q4. Theta prime equals 85 degrees. Negative 579. So let's see. I got to go this way. There's 360 of it. How much do I have left?
219.
219. So there's 90. There's 180. So how much more do I need to go?
40, 39 more.
39. So my reference angle on this one is how much?
39.
39 degrees. So theta terminates in Q2. Theta prime is 39 degrees. Radians. Ooh. Where's 13 pi over 6?
Or
In terms of with a denominator of 6, how much would be all the way around the circle?
12.
12 over 6. 12 pi over 6 would be all the way around the circle. So we've gone all the way around plus how much more? This is 12 pi over 6. This is 13 pi over 6. So what's the difference? 1 pi over 6. So that's pi over 6. So theta terminates in Q1. Theta prime is pi over 6. Three pi over 5. This will be fun.
Q3.
Q3,
Yes.
right here.
Yep.
What's your reference angle?
2 pi over 5.
Yep.
Trying to go quick so nobody won't.
Did he really?
Tell me you don't understand.
Is he watching the live by any chance?
Nope, nobody is. Are you going to comment first?
How do I watch it?
Hey, guess what? We're to homework.
How do I watch it, Ms. Harper?
Homework plus, don't forget that
Is
test.
it YouTube?
Yeah, Jay Harper class. Don't forget that test tomorrow with the 50 questions also. All right, so day 64 homework. I think that you have the free response on the back of this for tonight too. Yeah, day 64 homework and free response. So you got these 10 problems, which is just a lot of going back and forth, and then a free response calculator permitted.
There is so many J Harpers.
But it's Jay Harper class.
I did that.
Okay. Bye.
Why'd you?
I ended the stream. Sorry. You can still be the first to comment.